So these notes you went through everything, right?
Yes.
You understood distance and displacement.
Yes.
All the points.
Hmm.
Then distance, displacement from this diagram. Then the differences between distance and displacement. In this topic, when you are going to learning outcomes, you will not find distance and displacement, right?
Yes. Yes.
The definition or any explanation required, you will not find it. But to understand speed and velocity, you need the idea of distance and displacement. That's why at the beginning I started with distance and displacement. Then speed and velocity, already you know, right? Here I gave two diagrams to get the difference at a glance. And the formulas are also there. You see, speed, average speed, then velocity, average velocity. We will do some numerical questions on this. Then acceleration, right? Acceleration formula, you know, deceleration is negative acceleration, and the same formula we will use for deceleration, but that time the answer will come negative. And we have uniform acceleration and non-uniform acceleration. Uniform means always the acceleration will be same, right? That means the increase in velocity by time, the ratio will be always same. And non-uniform, there will be increase in velocity, but the ratio will vary. That means acceleration will vary. Okay. And for uniform acceleration in velocity time graph, we will get a straight line, steeper straight line. But non-uniform acceleration for speed time graph, we will get a curved line. Clear? And distance time graphs, we have all the things all together here in distance time graphs. You see here we are showing acceleration, right? Then we have constant speed. Then we have slowing down, deceleration. Then here is stationary. That means the object stopped. Right here. That means the time is going, but the distance remains same. Object is stopped. So here there are some, points here. The gradient. Here you got one point. That is the gradient of distance time graph giving us speed, right? If you are taking gradient of this part, then you will get the speed, right? And here also you can get the gradient by drawing a tangent. If you draw one tangent, then that tangent, if you take the ratio y by x-axis, then it will also give the gradient, which is giving you the speed. Okay, then if you don't understand anything, you should ask me. Okay, like I brought idea of tangent. If you don't understand, you can ask me, no problem. Then distance time graphs. We are here showing separately. You see, I added this diagram for some reasons. To show you, previously you only got constant speed, right here. Okay. Now this diagram we have also constant speed, but this line is a bit steeper and this line is less steeper, right?
Hmm.
Isn't it? So
Yes.
how they are different, these two? Both are constant speed, but there is difference. There is difference in gradient, right?
Hmm.
So what is the difference? Can you tell me in between these two
Difference
graphs?
between, sir, in the first graph, the object is moving faster, and
Uh,
in the second one, the object is moving slower.
Slower. Both are constant speed, but one
Hmm.
is having greater constant speed, another one is smaller constant speed. Okay.
Hmm.
And what about this? This one.
This one, sir, the object is stopped, is at rest.
Okay, this is stopped. This is stopped, and we can say the speed is zero, right?
Hmm.
If something is stopped, that means it does not have any speed. Okay,
Hmm.
we can say the object
Hmm.
is stationary.
Hmm.
Then in this diagram we are showing together, right?
Yes.
Constant speed. One is steeper line, another one is less steeper. So this one is faster, this one is slower, right?
Hmm.
And this one is in between them. This one, the blue one is slower than the faster one even, right?
Hmm.
But it is faster than this slower one. Clear?
Hmm. Yes.
Now displacement time graphs is, can you read the displacement time graphs part?
Okay. The details are similar as distance time graphs, except that the distance is now displacement and speed is now velocity.
Okay.
One minor difference. Okay.
Hmm. Read.
One minor difference. There is a straight line with negative gradient. It means that the object is traveling at uniform velocity in the opposite direction.
Okay, done.
Hmm.
Now this one.
Hmm.
Now the velocity time graphs, right? Different velocity time graphs.
Hmm.
The first diagram. Can you read the diagrams and explain the diagrams?
Yes. In the first velocity time graph, we can see that the object is at rest because the velocity value is 0. Uh, Secondly, the object is traveling at a constant speed and velocity has a value, and since it's a flat line, it's going at constant speed. The third velocity time graph shows constant acceleration. It means that as time is increasing, the velocity is also increasing at the same rate. Similarly, for the fourth velocity time graph, the as time is decreasing, at the rate at which the time is decreasing, in the same way the rate of velocity is also decreasing.
So the last one, non-uniform acceleration. You understand now how will be the graph going, right? For non-uniform
Hmm.
acceleration. And
Hmm.
here we have also non-uniform deceleration. So this one is clear, right?
Hmm.
And for distance time graph, you will get this type of graph for acceleration. That is uniform acceleration. You will get this type of graph, the lower one. Okay. And for deceleration, you will get this type of graph, the upper one, in
Okay.
distance time graphs. So why I'm saying it here, because sometimes you messed up, right?
Hmm.
With distance time and speed time graph. That time you have to think that first of all that it is speed time graph. So if the question is asking me about acceleration, non-uniform acceleration or constant acceleration, if it is constant acceleration speed time graph, the shape will be like this, right?
Hmm.
Hmm? And if it is non-uniform acceleration, the shape will be like this for speed time graph.
Hmm.
But for distance time graph, constant acceleration, you will get a curved line. Okay, steeper curved
Hmm.
line. So it's clear now, right?
Hmm.
Then can you read these points?
Yes. When the object is stationary, it is a straight horizontal line at zero.
Hmm.
When the object is undergoing uniform motion, it is a straight horizontal line at v meter per second, where v is the velocity of the object. For a straight line with positive gradient, it means that the object is accelerating. For a straight line with negative gradient, it means that the object is decelerating. For curves, it means that the acceleration of the object is changing. The area under the graph is the change in the displacement of the object.
So area under the graph, right? We are
Hmm.
now going to discuss that one. Next page, we will discuss that. Go to the next page, you see. Here in this graph, we are trying to give you more ideas, right? Already you got these ideas. Uh, you got these all points, the shaded, uh, these
Hmm.
shaded things you already got. And here, total area under the graph represents displacement. That means when they are saying area under the graph, that means this part inside the
Hmm.
box, not outside one, right? Area under the graph. Let's see now. They will give you only one line. For example, this line. Then the area under the graph will be this part. Okay. Here,
Hmm.
triangle. Now the example. They gave you this line,
Hmm.
right? Speed time graph, and they are saying to find the area under the graph, and the area under the velocity time graph is giving you the distance traveled. Area of the triangle is half base into height, right?
Hmm.
Base is 5 here, height is 50, then half
Hmm.
is for formula 125, then distance travel 125 meter. Done, right? This one is
Hmm.
simple, and this one, here we have triangle for the acceleration part, right? Constant acceleration part A. Then we have constant speed or constant velocity part B, right? The red one. Can you see?
Hmm.
Samjit?
Yes.
Then the third part, part C, that is constant deceleration. Again, we are getting another triangle. So the area under the graph for A, B, C, all these should be added for the entire journey. Total distance traveled by the whole journey, right?
Hmm.
We can do the working here. Can you tell me how much distance is traveled for constant acceleration part A?
Yes, that is 400.
How? Constant acceleration part.
Oh, constant acceleration. Achha. That's one is 200.
200. Again wrong.
Wait, 100, 100, 100, 100.
So look, you know everything, but you are doing mistakes. We can do it here, right?
Hmm.
You should do the working here. Do the working.
I'm a bit tensed.
Hmm.
I was
Can you
I
write?
was a bit tensed about the English. Yes.
Yeah, do it. Do the working here. Here only, in the screen.
Okay. 10. So it's, into 10 into 20, 500.
Look, you can do the working this way. Text box. Huh? This way, it will be easier. Half multiplied by what? Base. Base is how much? 10.
10.
Then height is 20, right?
Hmm.
Then equals 100
Hmm.
meter. Again, make another box here for the second part. How much? 600, right?
Uh, yes.
No,
No, no, 400, 400.
400. How 400?
Sir, 30 minus 10, which is
Hmm.
20, and that will be multiplied into
So
20
20
velocity.
multiplied by 20, right?
Hmm.
You have to be careful. Otherwise, again, you will do mistake. Then 400 meter for rectangle part, right?
Hmm.
Then another one. The third part, C.
Hmm.
How much it
Uh,
is?
is half base into height.
Hmm?
So half into 40 into 20
Half into 40 into
into 20.
20.
20. Hmm.
How 40?
Sir, 70 minus 30,
Okay.
that's the height.
Then how much it comes?
400.
Again 400. Okay.
Yes, 400.
So total distance traveled
The sum of these three, which is 900.
700, right?
900,
900.
not
Okay.
700.
900.
Yes, 900.
Okay. Now, if I ask you to find the average speed for the whole journey,
That's the total distance, total divided by total time.
yeah,
So 900 divided by 70,
yeah. Then what is the answer?
11.11, 2 by 9.
11
No, no,
point
no, sir.
what?
No, 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 sir. I think so. It should be more than 11.
Okay.
Wait,
What will
let
be the
me take
answer?
the calculator. 12.85.
12.85. Okay. 12.85 meter per second, right?
Hmm.
So you can solve the questions this way, right? Now
Hmm.
this part is done by me. I will ask you to the next part. You see, this part. This part can you do? Yeah,
Yes.
yeah, no. Yeah, continue,
Yes, sir.
please.
So that's first is the triangle. So um,
Ah,
yes, sir. I got it.
yeah, tell me.
Sir, should I okay find
Yeah,
the acceleration?
yeah. Can you do the working here, please?
Hmm,
Can you can you do the working here?
hmm. Uh, Sir, match the journey phrase with its line on the graph.
Mm-hmm.
So decreases the speed to approach the next station. That one is this part.
Which part?
Uh, this part. This part.
Okay, very good. Then,
Uh, and then the second part, which is departs from station within and increases within 30 seconds.
just hold 1 minute, huh? Tamjid. Assalamu alaikum, sir. Yes, who? Abdullah. Please call me after 1 hour, huh? 1 hour. I'm in class. I'm in class. Yes.
Hello, sir.
Yes, yes. I'm just sorry. One direct call came, right? That's
Oh,
why problem. So
no problem.
that one, the second one, deepers. Can you show which one?
Oh, okay, yes. This part.
Okay, great. Then next, the last one is very easy to understand, right?
Yeah, flat
We'll
line.
set a constant speed. The rest one. Now, the second question: find the acceleration over the first 30 seconds.
Yes, I can also do that. Equals to 60 minus 32 uh, meter per second square.
Mm-hmm.
Yeah, this one is the acceleration in the first 30 seconds.
Okay, so this one is giving you acceleration 2, right?
Hmm.
Okay, 60 first 30 seconds, right? 60 minus
Hmm.
0 divided by
Hmm.
30, 2 meter per second square. Then next,
Sir, I think so. There is one mistake here. It should be find the retardation over the final 60 seconds.
final 60 seconds. Okay, so
Yes.
it is
But
from 80 to 140, right?
hmm.
So it should be how much?
60 seconds. But here
60.
written
Yeah, yeah.
70
This
seconds.
one should be 60. So here it should be 60, right? This one.
Hmm.
So
Hmm.
if it is 60, then what will be the answer?
If it's 60, then should I show the working?
So
Should I show the working?
yeah, yeah, sure, sure.
Okay. Um, it's, sorry. Uh,
One, right?
yes.
1 meter per second square.
Yes.
Then
60.
what will be the total distance traveled?
Total distance will be 900 plus 3000 plus 900, 4800.
So here we can use the formula of trapezium, right?
Yes.
So what is the formula? Half into
Half into a plus b whole bracket into h.
A plus B whole bracket into H, right?
Yes.
So this one,
Hmm.
this one is giving you the answer, right? What is A? What is B?
A is 80 minus 30, which is 50, and
80 minus 30. That gives 50, right?
hmm,
So half into 50, right?
hmm,
Then plus
plus 140.
140. Okay. Then
um, into the height 60.
60. Great. So what will be the answer?
Um, Sir, here I'm getting a bit different. 5700.
50 plus 140, how much? 190.
190.
190 multiplied by 30, right?
Yes.
Because half and 60, if you multiply, it will become 30, right?
Hmm.
Then
Which is 5700.
319s are how much?
390 are 557.
57. Then 0, 0, right?
Hmm.
Meters. Area under the graph is giving you the distance, right?
Hmm.
So we are getting the total distance 5700 meters,
Hmm.
right?
Hmm.
Good. That's all, right? If they ask you
Yes.
to find the average speed,
Average speed.
then
Total distance. I will
5700 divided by 140, right?
140. 140.
Yeah, then what will be the answer?
Uh, 40.7.
40.7
40.7.
meter per second. Okay, done. So after doing these two questions on area under the graph, I think you can solve any questions, right? Regarding this.
Yes.
Thank you. Now we will go to the next discussion. Here, acceleration of free fall. Which one you did not understand, right?
Yes, I was facing some problems.
Yeah, where you are facing problem, can you read all the things? And where you are facing problem, there is stop.
Hmm. Uh, Sir, should I read from the beginning?
Yeah, here from the beginning. Yeah.
Okay. Neglecting air resistance, all objects experiences the same gravitational acceleration of 10 meter per second square towards the center of Earth. Note constant acceleration is of 10 meter per second square. The above means that the speed of
Till here you
downward
understood.
falling. Yes, yes,
Huh?
yes.
Downwards in questions, this all you understood, right? That means in past paper questions or Cambridge questions, when it's saying downwards, right? That is
Hmm.
towards the center of Earth, right?
Hmm.
The acceleration. Okay, continue.
The above means that the speed of a downward falling object, neglecting air resistance and other forces, that is not gravity or weight, will experience an increase of 10 meter per second every second.
Hmm.
Yes, at this part.
Hmm. That means you see here we have 10 meter per second square, right?
Hmm.
So you can say 10 meter per second every second. You know acceleration is velocity over time, right?
Hmm.
So here velocity increases 10 meter per second every second. That's why the acceleration is 10 meter per second square.
Hmm.
Clear now?
Yes.
Okay, continue.
It also means that the speed of an object traveling upwards will experience a constant decrease of 10 meter per second every second.
Okay, that means it's upwards. If you are going downwards, speed will increase. If you go
Hmm.
upwards, speed will decrease, and it will maintain the same, acceleration. Uh, in the opposite direction, we actually say deceleration, but it is
Hmm.
negative acceleration, right? So that
Hmm.
time speed will decrease 10 meter per second every second. Clear?
Hmm.
That time it will be deceleration. If you throw any object upwards, any stone upwards, it will become slower, right?
Hmm.
And the slower or the decreasing speed comes this way, 10 meter per second every second, due to the force of gravity, force of
Hmm.
attraction of the earth, pull of the earth, right?
Hmm.
So now we will stop here. Okay, our time's up for this meeting, and we will
Hmm.
join another meeting after 10 minutes. Okay, then we will discuss the rest part and also the worksheet. Okay,
Okay. Yes.
thank you. Now pray the Asr prayer.
Okay.
Okay, open the Asr
Yes.
prayer.
Yes.